Are we saying our names? Okay. Yeah.
Okay, one more to go. So the last presentation of this session and the last of the day is team number 21 SensoryWalk.
Hello everyone, thank you so much for joining us today. We're really excited to tell you about our project. We partnered with the Carter School and we worked to create a sensory system to help facilitate their physical therapy sessions that they carry out at the school.
Okay. So as she said, our customer is the Carter School, and they're a Boston public school that's located kind of by Northeastern. They work primarily with students with severe mental and physical disabilities, and we felt that the best way to show you who they are and what they're about was through a video. Where's the sound?
So just an overview of our project. Barbara, the physical therapist at the Carter School, has a program that she does every week with each student where they try and progress along a section of the hallway in the Carter School. It's about a 25-foot long hallway. And the goal is just to get them to move on their own, either with a gait trainer in their wheelchair or walking on their own. So she has had us create a system to provide a permanent source of audio and visual stimuli to kind of help motivate them towards the end goal at the end of the hallway. So our project is a 21-foot long number line installation, and each panel provides light and audio stimuli. And our system also helps automate some measurements that the school takes so that the therapists and the teachers there don't have to try and mark out on tape on the floor anymore how far the students are getting throughout the hallway and throughout the program.
So this is what our system looks like at the school right now. You can see on the left is our touchscreen user interface, and then attached to that are the 21 number panels. They're each a 1 by 1 square foot, about a 1 by 1 square foot area. And as the student passes each panel, the LEDs behind the number will light up, and the speakers will announce how far the student has gone. So after the 0 panel, it will say 0 and 1, etc. And so, well, this kind of got cut off, but here's kind of a closer look at the, I don't know if we can go full screen again. But here's kind of a closer look at the panels. There's a few things I wanted to note about these. First off, we wanted the system to look professional and school-friendly when off and when turned on. So we chose like a puzzle piece design and bubbled numbers to try to make it look like it fits in an elementary school setting. And we also chose red and yellow colors because a lot of the students at the school suffer from cortical visual impairment. And with this impairment, the red and yellow colors are the most distinct to them, and they can distinguish the numbers and hopefully see our display the best. And then on the top you can see just 2 boxes. We use these boxes to mount the system to the wall, and it also holds all of our electronics. The smaller boxes are for the single digits, and the larger boxes are for double-digit numbers.
So the staff at the Carter School have extension training to work with the students and not necessarily any technological savvy. So we had to make this system very easy for them to use and hide kind of all of the electronics and all of the very detailed stuff behind the scenes. So the way that the staff are going to be using the system is through a touchscreen user interface connected to our Raspberry Pi. This is a screenshot of like the home screen on the screen here, and the interface will allow them to create user profiles for every student so that it's kind of personalized for what each student would most respond to. So they can add users, delete users. They can also start the system based off of which profile is selected. And there's also a method to extract data from the system. So when the runs are happening, data is being taken in the form of timings between each panel trigger, and also kind of keeping track of how far the students are progressing down the hallway before the run is considered to have ended. And all of this data is formatted into an Excel spreadsheet at the customer's request. They are big on doing charts, and they like having Excel spreadsheets to be able to kind of post the progress of each student along the hallway. So this data is formatted to Excel spreadsheet, and then through a easy button on the user interface, they can export it to a flash drive and then do what they need to with it. These are the preferences that we also can set for each student's profile. A lot of the students respond differently to volume and brightness. Some of them have a harder time seeing or hearing, so we wanted to be able to turn volume and brightness up for some of them, or turn it down for others, depending on what the students, what would work best for each student. And a lot of the students also do not speak English natively at home, so we have 11 languages currently for each of those numbers being spoken aloud as they pass them, so that the students who speak different languages at home can hear what they're most comfortable hearing in the system. And a lot of these languages that we recorded were recorded by some of the parents of these kids, so they'll be able to hear a friendly voice and a familiar voice when they use the system.
So yeah, at the core of this system is the unidirectional motion detection. So the system is really orchestrated by the Raspberry Pi in the header box, and it's communicating with an I2C protocol to each of the microprocessors, which are contained in each of the 21 panels from the number 0 through 20. And each of the MSPs in the boxes are uniquely addressable, so they can communicate with the Raspberry Pi and know how to act according to the state of the system.
And so in order to implement the positive auditory and visual feedback for the system, we created speaker amplifier circuits and LED driver circuits. And so those two combined with the active IR sensor is how everything gets set off. And so at every foot of our product, it's basically a full system. The sensor communicates with the MSP430 and tells it when something is in front of the sensor. And then the LEDs will light up, and then the speaker will announce the number in the appropriate language. And so we've also decided to use two power supplies in order to isolate the ground noise between the two analog and digital PCBs.
It's kind of cut off, but the sensor's at the bottom of the puzzle piece.
Yeah.
So for the PCBs, we really wanted to make the system modular. We accomplished this by making them very easy to replace. You can see the color code on the right side of this slide. So whenever a piece breaks, in the unlikely event that a piece breaks, we have extra PCBs already populated that we are going to give the school, and all they have to do is unplug the wires that are connected and plug the new one in, and then reinitialize.
And there's a method on the user interface to reinitialize the panel with the proper address for I2C.
So our system was mounted on a 24-foot straight of hallway at the Carter School. Each of the polycarbonate boxes are anchored to the cinder block wall. The number panel line are screwed into the boxes in a numeric order to form a number line. The touchscreen display is at the head of the system, right next to a number 0 panel. So here's a video of our installation of our system SensoryWalk. is the video of our system tested by a school physical therapist.
That's on the next slide.
Next slide. Yes.
Right. Oh. Here. Touchy. 5. Okay, let's keep going. Oh. Whoa. Again. No. Keep going. There's 15. Right here. 15. There we go. Look at that. There's 20. Go. Oh, nice reaching, nice reaching. Oh, you did it!
Okay, so as you probably noticed, the lights and the sound weren't fully operational in that video. We spent 24 hours this weekend trying to install our project into the walls of the Carter School. We had everything laid out on the ground, everything was working perfectly. But at Sunday night at around 11 o'clock, we were just putting everything into the boxes, and the principal told us that he needed to go home and we had to stop for the weekend. So 11 p.m. Yeah, on the 24th hour of installation for the weekend. We were there for a long time. So we're going to go back on Saturday of next week to finish that. But for right now, they have that great number line. And you can see this is a quote from Mark O'Connor, the principal of the school, on what he thought about the project.
And we just want to say a special thank you to everyone in the ECE department, especially Professor Pisano, Professor Al-Sheikh, Professor Kia, all the GTS, especially Nathan and Nick, who came to help us install on Friday for a bit. And a very big thank you to all the staff in EPIC, especially all of the machinists and the student advisors who helped us build this entire system. It's a massive undertaking, and without their help, we could not have done it. And we also want to thank John Snyder, who helped us with our PCBs, and Professor Giles for donating some MSP 430s to our cause. So thank you. Any questions?
You mentioned ease of replacement ease of replacement. So I was wondering what the cost per unit was, and for the replacement, if you have like units pre-made so that they don't have to call you guys when you're working at all corners of the U.S.
PCBs?
Yeah. So we're going to give them 3 already populated PCBs for the MSP boards that have the sensors on them, and the cost for that PCB is $3, not including parts. The parts are relatively inexpensive. The most expensive ones are the VJT and the MSP 430.
And so that's for so you're anticipating the circuit board breaking and hourly need to facing or breaking the Facebook.
Yeah,
Correct.
They're very strong. We've tested that. We've dropped them quite a few times.
I replaced them.
Brett, what was the cost of the whole? I mean, really, this one was probably very expensive. But if other schools, I imagine, would maybe want something like this, like what would it cost for them to get it now that you've kind of broken it?
Well, the overall cost that we spent, I think ourselves $1,300 on the project, and we also got $400 of material purchased by BU, and then an extra probably $150 purchased by EPIC. So this was a really costly project because it was so big, and we tried to use the best materials possible. But I'm not really sure if someone else was trying to replicate it. If they wanted to use the same materials, it would probably be somewhere around the same cost.
All right, thank you. Okay, this concludes the presentation part of the program. All the students will now man their tables, and feel free to go around and try them all out. And we will come back here in a little over an hour.